Okay, so in 18 is the first problem that we actually have to use either A equals R alpha, V equals R omega, or S equals R theta. So it says a weed whacker is a grass and weed cutting tool that uses a 0.21 meter length of nylon string rotating at 6,200 RPM. And we know when it says RPM, that means what? Revolutions per minute, not radians per minute. About an axis perpendicular to one end of the string. What's the time needed for the string to sweep out an angle of 35 degrees? So for part A, it's just doing a rotational kinematics problem. We have, if we list our facts, we know that it's rotating at 6,200. Let me look at the units here. So I am going to convert this because notice this is in revs per minute and this is in degrees. So I'm going to get them both into radians and radians per second. So I am going to convert this. So rev per minute, I'm going to convert that, and I'm going to go from revs to radians, and from minutes to seconds. 1 minute is 60 seconds, and 1 rev is 2 pi radians. So that's going to give me whatever that is. Now, if that's how fast it's rotating, then it's not saying that we turn the weed whacker on and it gets up to that speed. It's going at that speed. So what can I put down for my alpha? 0. Because for the entire time, it's moving at whatever speed that would be in radians per second, that first number. Now it says, what's the time needed? So the unknown is going to be the time. And what is the time needed to sweep out an angle of 35 degrees? So 35 degrees, I'm going to have to convert that also into radians. So I'm going to go from degrees to radians. And actually in pi radians, that's 180 degrees. In 2 pi radians, it's 360 degrees. So I have 2 conversions to do here, and then once I have those, I'll be able to then plug into the formula. So what is my, if I work out the original angular velocity, what does that come out to be? Somewhere in the 600 range, right? 640 what? 49 radians per second. And if you convert the degrees into radians, what's that going to be? 0.61. Just is it another one like with 611 radians. Okay, so there are my facts, and so I'm going to pick the correct equation. So step 2, the only fact I didn't write down was the final angular velocity. So that means that the only formula that doesn't have the final angular velocity is this one. And since alpha is 0, that whole term cancels out. Rearranging it to solve for time, we divide both sides by omega O to get time by itself. And we get theta over omega O. So theta is 0.611 radians. And omega O is 649 radians per second. So we're going to get a very small number. And what do you get for the time there? Okay, so then that I'm going to write that then as 9.41 times 10 to the negative 4 seconds. So when they're really big numbers or really small numbers, that's when you probably want to write it in scientific notation. So that was the answer for part A. And now in part B, it's saying, assume that the length of the string does not change. Find the distance through which the tip of the string moves during this time. So we're looking for an S. Okay, it's really an arc length, but we're looking for an S. And so I'm going to be using the formula S equals R theta. I'm looking for the S. I have the theta and I have the R. So that's why they gave me that second part there where it says find the distance through which the tip of the string moves. Well, that's how long the string is. So that is my R. So 0.21 meters, that's going to be the R. And I already conveniently solved for my angular displacement in radians. So in part B here, all we have to do is just plug in the numbers. 0.21 meters times 0.611 radians. And that's going to give me the answer in meters. Because that's R and that's theta. Remember, theta has to be in, this has to be in radians. So that's in meters, that's in radians. And I told you that what I don't like about radian is just a way that gets us from something translational to something that is angular or rotational. So a lot of times you're not going to see it cancel out. It looks like the unit would be meter radian, but the answer is actually going to be meters here. And that comes out to be, what, 0.128? 0.128 meters. Oops. Any questions with that? All right, so I'll throw that up.